Okay. I hope you can all hear me. All right. All right, sure. Thanks. Before we start, I want to ask how many of you did what I asked you guys to research on about the handling of the outliers in our data sets. How many of you did work checked on it? It seems like no one did, right? Promise, were you able to check on it?
Okay, yeah, hi. I think I did.
Gideon, were you able to also check on it?
Yeah, I was able to check the difference between oversampling and undersampling.
Oh,
Hello?
yeah, I can hear you. Come
Okay.
again.
I said I was able to find the difference between undersampling and oversampling.
Okay, so can you tell us what the difference between the two?
Okay. So, from my own understanding, oversampling duplicates the minority class. So, if uh, a target variable, for instance, that's our variable, yes or no, right? So, I think the yes, I can't really remember the distribution, but like the one that is minority that have less data points, right? It duplicates the examples. Why in the undersampling it deletes the examples from the majority class, thereby causing uh, you to lose some informations that is valuable to a model, something like that. So an example is of under sampling is that smooth, SMOTE. Also, can't remember. So it helps to solve this imbalance problem. So the smooth helps. It aims to randomly balance the minority class by replicating them across the sample or population. I don't really know. So that's just what I could understand, but I don't really know when to apply it, right? Like I don't really know in this our case if we should use oversampling or undersampling. Thank you.
Promise, can you come again? The difference between oversampling and undersampling. I lost connection, so I didn't hear anything that you said.
Uh,
Yeah.
okay. Am I audible now?
Yep.
Okay, I said that oversampling duplicates examples or data points from the minority class in the training dataset. right?
Mhm.
While the undersampling will delete the examples from the majority class and thus uh, losing some vital information to a model. An example of undersampling is smooth, SMOTE. So it's a popular library used for class imbalance. So it aims to balance the distribution by um, replicating the minority class across the sample. So it's it's popularly used, but I don't really know the particular one we will use in this our case, right? Like I don't really know if we should use undersampling or oversampling, but from almost 80% of the time I've used this stuff, I've always used Smooth, and it's a popular library for that. Thank you. Okay.
All right. So, thank you. You've explained it very well for us. And today I'm going to make things clear when to use which. As you were saying, you don't understand the difference between the three of them, like when to use undersampling, oversampling, or smooth. So today we are going to also have a look at when we are going to use which. So aside that, yesterday I also asked you guys to check on, if I'm not mistaken, outliers. So techniques that we use to handle outliers. I told you that we have two techniques that I already know of. That's the z-score and IQR, or the interquartile range. And under each, we have capping and trimming. And I asked you guys to search when to use capping and when to use trimming. So Gideon, were you able to? Okay, so it seems Gideon is not here today.
I'm here.
Oh, okay, yeah, Gideon, you're here. Were you able to find out the difference between those two?
Okay, I went through your notebook. My network was not good. I went through your notebook and I didn't see what you just said. But what I found out was the log transformation and the square root transformation, like how to deal with outliers.
Okay, so how do you think we should deal with outliers if we have outliers in our data set?
Okay, like per my research, we have a column transform, a function transformer.
Mhm.
In that we have the log transformation when it's skewed to the left. Yeah, I think so. And also we have square transformation when it's skewed to right. I think that's what. But me personally, I haven't used that before. But now I've already searched on that how to deal with outliers, and that's what they gave me. But what you mentioned yesterday was very new to me, and I couldn't search more on that though.
All right, sure. Let me quickly share my screen. All right, so I'm going to quickly navigate to our notebook and rerun the entire thing before we continue. So let's just wait for a while. Let me see. It looks like today the network is not that strong over here. For some reasons, it's breaking. Let's see. All right. So let me quickly pull out some of my old notebooks, my old research that I've been doing. So this is a repository that I use during my training time when I was trying to learn machine learning, deep learning, so in all my, both AI and computer vision. So as I was saying, the only two ways that I know of handling outliers are using the interquarter method, which is called the IQR, and also using what? The Z-score. So when are we going to use interquarter range and when are we supposed to use Z-score? So in simple terms, when our data set is normally what? Distributed. Okay, so with these data sets, should I say this is a normal distributed data set? Gideon, is this a normal distributed curve? It seems to me that it's a right skew thing.
It's right skew.
Exactly.
Yeah, it's a right skew because
Okay.
you can see that
Okay. So
the curve lines is skewing up to.
okay. Good. So let me quickly open this thing back. The reason why I first did this is because I wanted to check if first of all there are outliers, and if I want to deal with the outlier, I have to check the distribution of what? The data. So if it's a normally distributed curve, then we are supposed to use Z-score. So in our case, this is a right skew, this is not, this is not, this is not, this is not. No, meaning we can't use Z-score. That's why here we were using whole capping. But when you come to Z-score for handling outliers, I'm trying to click on this notebook. Have a look at something over here. You see this one is actually not, this is actually a normally distributed curve. Let's have a look at this. I don't think this one. So this is perfect for it. Then this one too is a little bit. This one too, I think is okay for it. So going down, you could see that what I was using the capping method. Then I was using trimming. So if I'm to read this, then I'll say that what keep in mind that this method of using this call for capping trimming. So the outlier is valid only if the particular feature is what normally distributed. Okay, so we use normally distributed. We use this call when our data set is what normally distributed. So in our case, none of the data set is normally distributed. So we are supposed to use what? Interquarter range. Interquarter range. So with the interquarter range, let me quickly go back. We have capping and we have the trimming over here. Okay, so let's have a look at something over here. I think one will scale the data, then one will actually delete the data. So the question is, why do you want to delete something, a feature in your data set, and why will you want to, how should I put it? Why will you want to scale the data, right? So under normal circumstances, if you have more data, okay, and you think that your data set is huge enough for you to use to train your machine learning model, and you don't care of losing some, then you'll be thinking of what, how removing some from your data set. But if you think that the data set is not that much and you need more features and data to train your machine learning model on, then you use the other one. I've just forgotten the one which does the removal and the one which does the deletion. So let me quickly check it over here. I think I made some comment. Okay, so capping. Let's see. Wow, it seems I've totally forgotten. So for now, let's just randomly pick one to do it for us. But let me see this function. I think I'll understand what's going on over here. Okay, this copy. Just a minute. Okay, so this is what we are going to do. From here, I think you guys should check on capping and the trimming. For what I know, one is used to scale the data, then the other one is mostly used to delete some part of the data set. So let's use the capping method. Okay, let me copy this line of code and bring it here. We'll use it later. Okay. But I have one more question. Do you guys still think we should do more? We should still explore the data set more, because I don't think it's enough of what we've done so far.
No, I think we have to continue the modeling because we'll still like do much things, right? Like I think we can individually try that on our own, like the univariate, multivariate, bivariate plots. But I think we have an idea, right, of the EDA for now. I don't know, you know.
All right. So that's what I was also personally thinking. So you're right. And actually today is Wednesday. We are almost out of time. So let's move on. So the next thing that we are actually going to do is, let's assume we are done exploring our data set and we know a lot about our data set. We understand what our data set is telling us. So the next thing that we are supposed to do is to explore the data set. Is to pre-process this data set. So pre-process data set. Okay. Let me write some comments. Yes, Gideon. You can talk, Gideon. We are listening to you.
Yeah, we are having some missing values, or we are going to impute it in the pre-processing stage. Pre-processing stage.
Exactly. That's what we are going to do. So
Okay.
we are going to perform both feature engineering and we are going to do two things: feature engineering and processing of our data set. Okay. So we are going to handle all those outliers, the missing values, and everything in this stage. Okay. Okay. So now that we have successfully explored our data set, we are going to start. We are going to pre-process it in order for it to be ready to be used to build machine learning. Here we are going to deal with the following. We are going to deal with outliers, missing values, categorical features. Then the last one is scaling of our data set. Okay. But you should keep in mind, anytime you finish exploring your data set, you should write something called observation. So let me give you an example. I just remembered it. So something like so observation, right? So the what did we whilst exploring the data, we realized that what some features had outliers in them. That's some of the things. Some features had null values in them. Some features uh, are categorical, whilst others numeric. And we realize that none of our features were normally distributed. If you're a data scientist, and the reason why I'm adding all these things is because sometimes I'll see a notebook with nothing. The only thing I'll see, so for example, like this one that I did over here, where is it? Like this one, I have little comments in them, which is very, very bad. If you're, let's say, a beginner, you want someone to see that you are a professional, you know what you are doing. And if you give them a notebook like this one, even though we've not done enough, there's no plenty comment or something, I think this is enough to convince someone that what you are a professional, you know what you are doing. And especially after exploring your data set and you give an observation of what you've done down here, the person will see that, no, this guy is solid. He understands whatever he's doing because you've explored the data set, you've given your observations. This observation is very low. I'm just showing you that after you have after exploring your data set, you should be able to give your observation, what you've seen in your data set, so that any data scientist who come and see your notebook, he will understand everything that you are doing. Okay. So before we start, let's quickly split our data set. So split our data set into training and test set. Okay, good. So let's import the library that we are going to use to. I always come up here again and import my libraries. All libraries will be imported from here. So from sklearn dot think model selection, import train test split. All right, we are good to go. But before that, let's split our data set into features and labels. Okay, so x is equal to df copy dot drop loan equals and axis equals 1. So axis equals to 0 means the actual values, okay, which are the features. But if you point it to 1, it will set for it at the column side and pick the column name that we want to drop. We now want what y. So df copy slash loan status. Display x values, x dot head, and display. Make sure y. Great. So now we splitted it. Now let's split our data set into training and test data set. So x train, x test, y train, y test is equal to train test split. Okay, so we put in our x, our y, then our test size, we want to use 0.2, just 20% for our test data. Then let's use random state to, let's say, 45. So that anytime we run this line, remember that anytime you try to run this, if you don't have this here over here, it will actually, how should I put it? It will actually select randomly. But the moment you put random state is equal to 45, and anytime you try to, this 45 can be any number. It can be 0, it can be 1. I just like to use 45. So what it means that the moment you keep on running this notebook, you still get the same subset of data set in train test over here. Okay, but there's another way. Since our data set is not balanced, I'm not going to use, and assuming I don't want to handle imbalanced data sets, we have something called stratify. I don't know, stratify equals to, is it y or x? Yeah, if you do it this way, it's going to split your data set in such a way that it's going to put into consideration for the imbalance. You today your the other assignment for today is to check on this thing, stratify. Okay, it's used when you are trying to derive its classifications model, which has whereby the data sets are not balanced. Okay, so now I've run it. Let's check for display X train data set. So X train, what's head? Let me see some. Okay, let's do something other. Check the shape of each asset. So print. So there are hot. Oh, sorry. It's not supposed to be here. So have a look at something. You see that what in our training data set, we have more data set in our test data sets. We have sorry, so this is supposed to be Y train. X test. Y test. Okay, so our training data set contains more data than what our test data set. Okay, but let's see the shape of the original data set. So let's check if you combine this and this, we'll get. See, so what this means that we have what says 4 rows and 12 columns. Okay, so if we add 491 plus 123, we get what says 4. Okay. Okay. So now that we have our data set being splitted now, we are going to use something called pipelines and column transformers in scikit-learn to pre-process our data set. So let me quickly import them over here. From scikit-learn.com. See this. Okay, so let me see how to import column transformer. So it's actually compose. Okay. Let's see. Column. Okay. Spelling. Okay. And let's come down here. Okay, good. So column transformer, what it does is that it helps us to pre-process our data set in such an easier and much more faster. So you can use combination of column transformers and pipeline to pre-process and train your machine learning model at a go. So let me just demonstrate it and show you how it works. So but before that, let me get the categorical features thing. Okay, you already have it here. Great. So let's set up pipeline for categorical features. So that pipeline is equal to pipeline. So the first thing that we want to do here is to handle the missing values inside the categorical features. Okay, so missing. Step 1. Missing value. So this, I'm just giving it a random name. Then we have something called simple imputer that we use to handle null values in scikit-learn from scikit-learn. So let me quickly import that library to as well. So think import simple impute. Let's see. Okay. Okay. So I'm going to use this to handle the outliers in our, to handle the missing data in our data set. Okay. So I have to define a strategy. Okay. So the strategy is what? Constant. Now, what value do I want to put in? So let's say fill value is what? Missing. So what I'm saying that when I pass in the categorical features into this pipeline, it's going to replace all the missing value with a constant value known as what? Missing. But under normal circumstances, real world, based on the type of data set, they may drop it, they may replace it with some specific features and all that. But in our case, we just want to what? Replace it with a missing value. Then after we replace it, we want to what? Convert it. Okay. It's a categorical features. We want to preprocess it to numeric. So the next step is to what? One hot encode it. Encode our data set. And this one, we are going to use a library called one hot encoding. So let me go up again. Let me say pre-processing one hot encoding. Okay. Then there's one more for the labels too. I'm going to use label encode. Label encoder. Okay. Let me quickly come down here again. On hot encoder. So here, sparse. I want to set it sparse and hold there. If there's no unknown value, I think it's handle unknown to ignore. So what I mean in this line of code is that after we replace the null value, it will pass the results to this line, and this line is going to convert them, all the missing values in our data set, which is the categorical features, into what? Numeric. And the way it's going to handle is that after it has converted it from categorical to numeric, if the data set is too huge, very, very huge, it will move it into a sparse value. But here we are saying that we don't want any sparse value. We want to see the actual value. And here, remember, we are going to pass in the entire data set, meaning that there will be both numeric and categorical features. So if it is not a numeric feature, what do we want to do? We want to ignore it so that it won't touch it at all. So this is the pipeline for our categorical features, and we have to do another one for our numeric features. Let me quickly do that one. So this one to step 1, send value. Simple imputer. So this one, the strategy that we are going to use, we are not going to use constant. We are not going to use mean. Let's say we are going to use either mode or median. So let's say median. Okay. The reason being so is because if you check our data set, it's not normally distributed. So if our data sets were to be normally distributed, we will have used mean to handle the outliers in our numeric features. But since it's not normally distributed, we will have to think of mean or mode. Okay. Then I think that's all over here. And from here, we want to scale our data set because we have some data sets which has maximum, which, for example, the outliers that we have in our data set. So we are going to scale them all, okay? Step 2. Scale data sets. And with this one, we have so many ways of scaling data. We have standard scalar, we have robust scalar, we have min-max scalar. There are so many, but I'm going to use min-max. We use standard scalar. Remember, when our data set is not normally distributed, if it's not normally distributed, and let's assume there are outliers too in our data set, standard scalar doesn't work well with outliers. Okay, so since we have outliers in our data set and we've not handled them, I'm going to use min-max scalar. I think it's from preprocessing. Exactly. So I'm going to use min-max scalar, whereby it's going to scale it between 0 and 1. Great. So we are done. Now let me quickly run it and see. Good. So now we are going to define our column transformer over here to call them and pass in the column name that we want to work with. So define column transformer. So here we are going to call categorical features. So cat pipeline. We are going to pass in the cat pipe, then the features. So we want the features. Remember, we've done some tricks in our data set. So in order for us not to get any restriction, since you are dealing with the training data set, let's do it this way. We've already learned what this means already. So we want to include category objects. And after that, let me copy it here and test it before. Okay. Just select the types, include category object. Okay. So now we are passing in, we are calling the pip pipeline, and we are passing in the columns feature, the categorical features for it to process it. So now the next step for us to do is to what? Call the numeric hot pipeline. Okay. So we pass in our num pipeline and pass in our, let me copy the same thing. But since this time around we want only numeric, we are going to exclude them so that it will give us what numeric features only. So let's quickly run this line of code. And now let's fit on the training data set. So let's say column dot it. Okay. And let's pass in the training xtrain and run it. So let's check for whatever is going on over here. The strategy parameter. Okay, so it's asking us to put either median. Wait. Oh, sorry. I did a spelling mistake over here. Wait, so now it has run. Let's see what's going on over here. So, okay. So now remember that we fit on the training data set. Now we have to transform. So whilst transforming, we are going to get a new set of data set. Okay, so I'm going to name it xtrain. Okay, so if I let me do this, a new xtrain equals to column dot transform. Now we have to do it on the training data set, transform on the training data set. So transform on both test and train data set. So now new X test. Let's transform the test data. Remember, we only fit on the X string, but not on the X test. We only have to transform on the X test. Okay. So now, okay, so column has no attribute transform. Okay. Great. So now let's check our result, our new data. New X string data set. So new X string. So there's the value now. Now hot, you can see the hot, there's no hot categorical features. Now everything is just numbers. So now let's do the same thing for training data, test data set as well. Okay. Now we are left with one more preprocessing to do, which is what the Y. This one, if let's say I want to display Y train, I'm still getting yes or no. We have to what preprocess this one too. So anytime you are trying to preprocess the label data set, always use label encoder. That's what it's meant for. Don't use label encoder for anything else again. Okay. So I'm going to initialize.
Right.
Yes.
Yeah. Sorry, I don't want to distract you, but I realize that most of the values are now 0 and 1s.
Yep.
So that's intentional. Is it because it's one hot encoding or something?
Exactly. So what one hot encoder does is that it converts all the categorical and object values into numeric. So one thing you should remember that machine learning algorithms does not work with something like this.
Yeah. But okay, fine.
Can't work with male, null, graduate, and stuff. So we have to convert them into numeric. That's why
Okay.
we've been able to do it this way.
Okay. So why 0 and 1? Why not 0, 1, 2, 3, or maybe 2 and 3? Why specifically 0 and 1?
Okay,
Is it
good.
like,
So
yeah, I'm listening.
all right. So in fact, let me give you an example. You know that under normal circumstances, from our computer science background and the little knowledge we have in computer science, you know that normal computers, their binary code, I think, is zeros and ones, right?
Yeah.
Exactly. And it seems like machine learning algorithms has been designed putting that in mind. So they mostly works and perform well when the data sets are in zeros and one.
Okay.
Mostly. Exactly. So you're going to see many data sets which has been processed into zeros and one a lot when you try to see machine learning applications. Are we cool?
Yeah, sure. You can continue.
Okay. So let me initialize this label encoder. I'm going to give it name, then label encoder. So now I'm going to fit. Remember, we fit on training. We don't fit on test. So new Y train is equal to label dot. We can do both fit and transform at the same time on the training data sets. Remember, so Y train and new Y test equals to label dot what transform and what Y test. Let me do something. Always comment is very essential. So preprocess label features. If you give this notebook to someone and you tell the person that you are now learning data science, the person or machine learning, the person will think you are joking. This little thing that we've done. But if it would be a production grade workload, I will have gone into much more details because we've skipped so many things. Even exploring the data sets, there are so many things we could have done. But since this is just a demo, I don't want us to go into much details and waste much time. So let me quickly display what we've done. So display Y train data set. So new Y train. Now display Y test data set. So new Y test. So you can see that we've now convert them all into what? Numeric. So now, but there's an issue here, this side over here. I want to convert them in such a way that, like how we can see this, I want to bring them back here. So let's do some little tricks over here. Let's do pd.data frame. Let me show you something and put in the new X string. So, and let me quickly do something to over here. df copy. Have a look at something. You see here we have male. So this is how it worked. Okay, it will pick this column since we have one male and female. That's the only values we have here. So 0 will be male and this will be what? Female. Okay, so this is 0 because this is male. Okay, so 0 means male, then 1 means what? Female. Okay, 0, then what? Since male is the first value, that's why it's male. Then the next one is what? Female.
Okay.
That's how it's going to work. And for you to know the difference between the numeric features and the categorical features, see, it converted everything into zeros and one, but here you see we have 0.7 something. That is the numeric features in our data set that got scaled. Okay, so in order for us to bring back the columns, let's do something quickly. I think columns, then this is column. It has something called dot thing transformers. Let me see. I'm mistaken. Let me see. Let me see. This one, transformers. So the next thing we want the pipelines, the one hot encoding happen here. So we are going to use this one. Let me quickly do it fast. I want the feature names back. So you just be quiet and look at what I'm doing. I'll explain. Let me do it this way rather. Okay. This one. Now the next thing, I'll just copy this one. Okay, so you say it's wrong. Why? Okay, I know why. There we are. And the next thing. Cat pip. Let me see. I've forgotten how to do these things. Let me see. Okay, so let's do this. I think I have some source code that I can reference. I don't want to waste. It's almost time. So let me. I think I have some. Let me see. Just a few minutes. When we convert it into a data frame, then we close for the day. Then I'll take all the questions that you guys have for me. No, this won't work. Minute. So this is just a Python code. How do we access? I think this is a set.
Yeah. Okay.
Just
You want the pipe stuffs?
pipe as in. If anyone can help, you can help. Oh. I'm struggling over here.
What do you want?
I want to access. See, we have two elements here. Oh, okay.
Yes.
Okay,
So
there are actually two.
mm,
This is supposed to work. Let me see.
okay. What about if it's one? Okay.
One. Let me check. Named steps. Okay. Yeah, that's named steps. It's not work. Oh, because there are two. We have this is a different thing, and this also a different. Oh, okay. Great.
That's what I wanted to say, but I was I was scared as Charlie.
Then named steps. Yep, we are almost there. And I think the next one is one hot encoding is over here. Okay. All right. So now we are inside the one hot encoding. And in order for us to get the value name, we just have to add dot get feature names out. Now these are the feature names. Okay, so it's actually started with female. So let's quickly display the data set, the new display new X string data set. So new X string, okay. So the no ed.data frame. Okay. So what it means is that the first value is 0, which is this one, female. So female, then male. Let me actually display that actual value. Display EF copy. A minute. Okay, so let's see. Male 0. I'm coming. I thought someone raised their hand. Okay.
Yeah, it's me. Sorry.
Oh, okay. So yeah, I promise I'm listening.
Okay, I want to know when we should implement like this sklearn pipeline, because like if you have a large columns and if like a column have a very large categories, let's say like 90 categories, I don't think it's advisable to use dummy variable like one hot encoding, right? Like it's going to be too much. So I don't know, I'm just like confused because I have a project that have categories that they're up to 100 and something, right?
Can
Just
I
a column.
can
Okay.
I ask or say or something? So you mean
Yeah.
one column,
Okay.
let's say male, let's say gender, and then let's say nowadays we have transgender and plenty things. So like maybe you have male, female, double male, double female, male, female combined, those kind of stuffs. Is that the scenario you are asking?
Yeah, yes, exactly. Like if there are
So
too many
if,
categories,
if
so it's
if
they're
you
going
have
to is
so
yeah.
if you have like a situation like that, can you like maybe divide that category into another subcategory so that you can have um like you can do your one with the encoding? You get what I mean?
Yeah, I don't really know.
Like
I
you
don't
get
think it's possible. Yeah.
right, you get what I'm trying to say.
Oh, I get you guys. So
Uh-huh.
this is simple. There's only a very simple answer to the situation like this. Remember, this column that we have is we now have 19 features. That doesn't mean that you're supposed to use all the 19 features. Remember we have different feature. We've not done something called feature selection.
whereby we select the most important features. So if you were to have so many data sets like that, let's say a data set which has so many columns, like as you are saying, you have to perform feature selection, whereby you have to select. We have techniques that we use, and some of these techniques are dealing with, let's say, the null values by, let's say, dropping some of the values if they are necessary. We have some whereby we remove duplicated features. We have some whereby we have something called quasar. Quasar is a technique that we use to deal with when we are dealing with feature selection. Wait, I think it's even here. Let me see. I think I have to share this notebook. Let me see. Just a few minutes. Oh, I've forgotten where I placed this thing. But there are so many features. Let's search feature selection techniques. Let's see what they have here. So see, we have filter method, we have embedding method, and have what wrapper method. And here you see we have our filling values, missing values. This is the filtering method. How you are dealing with missing value. We have what information gain. We have chi-square test. We have what Fisher score. With embedding method, we have what regularization. Where we have the L1 and L2. We have random forest importance. When you come to what wrapper method, we have what forward feature selection, backward. So the thing is, if you have huge set of data sets, that doesn't mean that you are going to use that huge set of data sets. You have to perform something called feature selection, so that you'll be able to select the most important features. And there's no standard that 5 is the most important features, 10 is the most important features. So what you mean that, assuming if you have 19 features, 90 features, and you deploy the application into production, and I want to use the app, I have to input 90 inputs before I can get a result. No,
it's not what I mean. I mean category in one feature.
I know.
That's what I mean.
I
right?
know.
Yeah, that's exactly what he's saying. The selection.
So meaning that in such case, you have to perform feature selection.
Selection. You can't implement all the 19 different types, whether male, female, male chicken, male bird. You have to select your important, whether you are, because depending on the situation, what are you training the machine for, or what are you trying to for? So you divide the data, and then you train and do the analysis, and then you give a report.
And
and
so,
before you even come here.
And so, if they are all important, like all the whole 90 are important, what should I do then?
Okay, so if all the 90s are important, you don't have to. There's no. I don't think there will come up a situation whereby you will see 90 features being trained for a machine learning application.
Never.
There's exactly 90. I doubt. I think the highest will even be 30.
Okay, like I'm trying to predict salaries, right, of every like job in data, like data engineer, science analyst, and so on. So I have like they're up to 90 of them, and so
No, that's
if yeah, they're more. So like I was trying to like use the top 20, but I was like, I don't know if it's like I'm going to lose some information if I don't like use all of them. Do you get? So I was like, is there a way I might use label or the like encoding, right? Since
so in
all
such
that
a
is
case,
not important. Yeah.
so first select the most important data. Okay, so we have tests, a way of performing tests. We have there are so many tests that you can perform before you select the most important features. Okay, so in your situation like that, that's what you have to do, because imagine one hot encoding such feature, you're going to get so many columns that that some of them even won't be necessary for your application. Okay.
Okay.
All right. So it's
Thank
time. You are welcome. It's time. I don't know. Let me quickly just convert this into. Let me see. Just a few minutes. Let me convert everything. Then we close for the day. So. If I let me put this into a variable, one hot. Okay. So let me. I'm going to convert both this variable one hot with numerical variables. I'll explain what I mean very soon. Just a minute. Yes. Instead of this, I don't know why anytime around this line of code. Okay. Exclude this. I've forgotten that I've already have it here. So let me just copy it. Okay. Just a minute. Lumps. Okay. Let me just do it manually. It's almost time. But I think. Okay. Extreme. Remember, the first values are the converted, which is the one hot encoding. So we have the column names over. Where are the column names? Here. So let me copy the column names from here. Remove this line. Done. I'm coming. I just want to convert it. Then we go our way. So now the next thing that we need is the category numeric features that we want hot, the one we skilled. So that one will be this one. We arrange it well so that I'll know what's going on. Okay. Let's see. Great. Now we have everything here. All right. So let me put it in. So BF. Now let me just make it extra. Right. Let me do the same thing for test. X test. Now let's display train data set. X train. Head. The test data set. X test dot. Great. So we are done. Now we've how should I put it? It has come back to its original hot form. Okay, so there's it. So these are the features we are going to use to train our machine learning models. So I think that's all for today. We've spent a lot of time. It's almost time. So now I want to take any questions that any one of you have for me to answer. Please, any question that you have, just bring it on board. We've done so many things. Tomorrow, I'm sure we'll be done with building our entire model. Then we'll put them through our pipelines on Friday. Then we'll wrap everything up. Right. So is there any question? All right. Yes, promise.
Okay, thank you. So, are we going to like have a train split, like a train script, right? Like from the thing I understood, I went through the repo and I saw a place you created like train.py, right? Test.py and so on. So eventually, are we going to convert this notebook to a train split a script we are going to run and do everything?
Exactly. So inside our pipeline, we can be using the notebooks inside our pipeline. That is going to validate, build, and train the machine learning model. So with that, we are going to use the training script.py that are inside the notebook, inside the repository that I created. Okay.
Okay. And so are we going to use these pipelines inside there, or is it going to be like exactly like this notebook now? Everything we just did in this notebook, is it the same thing that will be in the train script?
Exactly. So as we already know, let me give you an example. So let's say we have Bright scripts, then Python, then train.py. We are going to have like our usual things from sklearn dot let me see, ensemble import, let's say random forest classifier. It's going to be the same thing where let's say CLF is equal to, then we do our fits and stuff over here. It's going to be the same thing, so that we will run this Python script through our pipelines like this. Okay, so that these pipelines will be calling the training scripts and stuff. So that's the main thing. Have I answered your question, Promise?
Yes, thank you.
You're welcome. Please, any other question for me? Please ask your questions.
Yeah. So my question is I was having some personal problems when I was Actually, I'm able to, because your repo is public. I mean, when you are done, you push to your GitHub where your Jupyter notebook is. I can actually open it with Collab. Google has like some Jupyter something that you can. It's called Google Collab. So I'm
Yeah,
able
I
to
know.
see. Yeah, so sometimes I don't want to type everything I can, so that I can just copy what is there and paste it when I'm doing it. But facing some small issues. I don't know whether, because I'm thinking that even if you do, there's an import that you import, and even we don't use it, everything is supposed to work. But there's a place where I'm finding the issue is where you are downloading a data set. So I think it's something that is just. So I wanted to know if, because everything from what I know about Jupyter Notebook is, even if the person has gotten to a certain place, which is far ahead, and you copy what is the commands from the beginning to you should be fine. Everything should work out.
It
Okay.
won't, so in your case, it will actually won't work. The reason being so is because, let me show you something.
Okay.
This notebook that we are running is actually in AWS, and it has a rule which has been attached to it. Let me see. We have something called IAM rule. This is the IAM rule. And this rule has permissions to communicate with S3 buckets. This one's over here. So this time around, your own, you are running it outside AWS, and the rule is not attached to the code lab
No.
that you are using.
I don't know if.
So you won't be able to access these resources unless you run it inside a Colab, a SageMaker notebook.
Yeah, I'm running
Which,
it in a SageMaker notebook. I just opening yours so that I can just see as a guide. I'm actually running it in my SageMaker notebook.
and your own is not working, right?
It was not downloading the data, but I created an actual folder in the S3, and I also called raw datasets, and I uploaded the training CSV datasets there.
And
So,
what was the error that you were facing?
oh, I have the error right here. Let me just open this.
Sorry.
Yeah, found not found.
Are not found.
Yeah, I can share my screen if you don't mind.
Yeah,
You can
sure. You can share
Yeah.
your screen.
This is it. Can you see?
Yeah, I can see it.
Yeah. So I went to get my instance. I got my buckets. So it's almost the same. The only difference is this, I changed it to mine. I was able to get all of that. And then you see the row.
Wait.
That's mine.
Exactly. So let's see what's going on over here. I've still the download file.
So I'm actually
It's saying file does not exist, and let me see.
and then I can show you my history in my S3 buckets. Is I created a folder called raw datasets, and I put I downloaded this one, then
Go navigate into your S3 bucket and let's have a look.
there's my S3 buckets. This is my supposed to be in the database. I put it. I created this folder, and I put the CSV here. Uploaded it.
Okay, so hold on. Let me give you my own over here in the chat, and let's see what will. Please, we will close right now. Just give me a few minutes. Let's help him solve his issue. Where is it? Okay, so use this one. It's in the chat.
Okay. Try this. Okay. Copy this one. This one. So I'll replace this one. Okay. So let me run this one. Let me just run from the top. I run the top first, just in case. Let me run this one. And run this one too. This one. Yeah.
So scroll down a little. Let me see what's down. Scroll down to see the end of the error message.
Okay.
Okay, scroll up. Oh, okay. Go up. No, go up. I want to see the code I gave to you.
Oh, this is the code.
It's okay. So now click on the data folder.
Data.
Yeah, the data folder. Click on raw. All right. So try accept.
So because yeah. My problem is it even downloading the distance at all from the default path? First and foremost.
Data dot.
Oh, okay, fine. It's even in the first try.
Yeah.
Uh-huh.
No, the try is trying to read it. If it fails, it's supposed to download the file. Let me see the part of the default database, a data set part in S3. Go up
There's it.
where we set the variables.
Because I created this folder and I placed it there. So I'm thinking that it's supposed to even generate a false or something like the try. That is not there.
Raw data set. I'm coming just a minute. Slash loan prediction.csv. Raw data set. It seems like your try and catch blog is not even working in the first place for me.
Anyway.
Wow.
Okay, can we print DF? Is it possible?
The data set does not exist. It has not yet been downloaded, so forget about even that line. Let me see something. Save file not found. Why is the try and catch block not working? Can you go back to your notebook?
Okay.
Save what you have here. Save it. Click on the save button icon over there.
Icon. Where is it? Okay. Done.
Yeah. Close it and open Jupyter notebook. Not Jupyter Lab. Not the other one. Not this one.
Jupyter. Where is it?
Go to your SageMaker.
Okay. So I should open Jupyter notebook, not Jupyter Lab.
Yeah, open Jupyter Notebook and let me see something. I know that's not the reason, but I want to understand. Oh, it's time. Please just give me some few minutes. Just at least 5 minutes, please. I beg you.
Guys, sorry. Is it okay? Is it because this one is open?
I doubt.
Okay.
Wow. Still, it's time and okay.
So this is
Okay.
I don't know why it's taking long. 5 just a few seconds. It doesn't come then.
Exactly 9:35. It doesn't come then. We stop for the day.
Yeah. Yes. Takes more than 9:35.
Yeah. Yes, promise.
Okay. While we are waiting, I wanted to ask that time, the first day or second day when we are doing our setup, was that like continuous integration and deployment, like creating those environments in GitHub Actions and so on? Are they the continuous integration and deployment pipeline?
Exactly. So we've done some. Now we have to do the same thing for the machine learning model. So whereby if let's say we are not around and a data scientist upload a new data set in our database, that's the S3 bucket. It should trigger the pipeline to pull the data, run data validation on the data set, try to pre-process the data set, build a model, evaluate it, and deploy the model to a particular environment. The pipeline should be able to do all those things. So we've done the first part by using infrastructure as code to set up our resources. That's using both CI/CD and infrastructure as code using Terraform. Now we are left with using CI/CD to do everything that I have done over here. The pipeline should be able to do both of these things, starting from running checks on the data set and processing the data, training the model and deploying the model to a particular environment. So all these things will be done in the pipeline.
Okay.
All right.
Thank you.
You're welcome.
Okay.
So let's just close for the day and we'll know what to do. I'll just let me see. I think it's best if we watch the video again and this time around take your time and see how everything is being done, because everything that I'm doing, I don't skip everything. I make sure that even if it gets errors, we solve everything together. So I'm sure if you just watch the video again, you'll be able to pick it from there. Trust me, such a situation has happened to me before. I thought I've watched everything correct, but the moment I rewatch, I realized that I missed something. Okay. All right. So if there's no question at all, if there's no question, absolutely no question, I think it's best if we close for the day. Okay. So thank you guys.
It's open though, so yeah.
But But let's close. It's time. Don't worry.
All right, sure.
Promise, do you have any other thing to tell us?
No. Thank you.
All right.
Yeah.
Just
I also want to ask that if anyone is working on like actually doing the physical and he has any challenges or something, you can contact me. And if you have anything to share, you can also maybe it might even help so that you can all like be on the same page. I don't know.
yeah, sure.
In terms of setup, for us for the theoretical side, and I think Senior Bright is already doing a good job. So, but yes, still yes, even theory two is also welcome.
Sure, Mr. Rodney. Thank you guys. Thank you guys. Since we have one new guy that I've not seen before, who is Joseph. Welcome, Joseph. I think we will be ending very soon. We have the videos available. If you want to watch from scratch, it's available. You can just go and get them. I think I'll put the link in the group. It's a full playlist. I think there is our fifth or sixth. I don't actually know. So you can get all the videos from there and watch it again and see how things are going so that you also be able to pick it from there. Okay. So thank you guys so much. I really, how should I say it? I appreciate your time, and let's meet tomorrow and Friday to finalize everything. Okay. Thank you so much. Bye-bye.
Thank you too. Bye.